let's take a look at another problem that involves inverse tangent. And so where we're given an output of tangent and we're asked to figure out an angle measure. So here we're told that tangent of x equals negative 0.2. So we're given this piece of information. So we're given a negative slope. And then we're also informed that cosine of x has an output that's negative. And so this first question is just, given those two pieces of information, can we figure out what quadrant our terminal ray is going to fall in? So let's do a little bit of thinking about what this represents, and then we'll sort of explain it in words. So we know that tangent is negative 0.2. And what that tells me, this piece right here, is that for sure, and I'll use blue to represent tangent, my tangent line, my terminal ray is going to create a sort of line with a negative slope. So sometimes what I like to do is I'll draw on a negative slope through the origin, and I'll notice that with that negative slope, my angle would either fall in quadrant 2 or quadrant 4. Those are my only two options given a negative slope. But then we're given this second piece of information. We're told that cosine has to come out negative. And if we remember, cosine represents a horizontal distance that our terminal ray is from the vertical axis. So you can also think of that as sort of your x coordinate on your unit circle. You know, sometimes we think of it as. And so in thinking of it that way, where are our x values negative on our coordinate plane? Well, they're going to be negative on the sort of left side, which means in quadrants 3 or quadrant 2. And so the place where the two pieces of information overlap is quadrant 2. So if I'm asked what quadrant is this angle going to fall, the terminal ray going to fall into, it's going to be in quadrant 2. So quadrant 2 and, you know, we talked about because tangent has a negative slope in quadrant 2 and quadrant 4, but cosine, which represents our x-coordinate or horizontal distance, is only negative in quadrant 2 and quadrant 3. Those two pieces of information overlap in quadrant 2. So I'm going to keep that in mind as I work through the problem. So I'm looking for an angle measure that's basically going to be in quadrant 2. So if I'm thinking about quadrant 2, what do I know about sine in quadrant 2? Well, if we remember, sine is our vertical distance measured in radius lengths. And since in quadrant 2, our vertical distance or our y coordinates end up being positive, sine of x will be positive because sine represents the terminal ray's vertical distance from the horizontal axis, aka our y coordinate, which is positive in quadrant 2. And the reason I like to think about this is you'll notice in the future questions we're going to be asked to find the value of sine and cosine. So it's always good to know sort of upcoming, okay, my sine output should be a positive number. If I don't get a positive number, I did something wrong. So we're asked now to use arctan or inverse tangent on our graphing calculator and maybe some symmetry to figure out the value of x on the interval 0 to 2 pi. So this right here tells me I'm looking for an answer in radians. So I want to make sure my calculator's on the right mode. And I already put this in the calculator, but you could pause for a moment and put it in yourself. And when you put arctan of negative 0.2 in your calculator, you will come out with negative 0.197. Now notice we are given a measure of an angle in quadrant 4, but that is not the quadrant we're looking for. Remember, we're looking for quadrant 2. And so I like to draw myself little pictures to help me with this. So if I notice, I'm basically given this measure right here. That's going to be 0.197 in the positive direction or in the negative direction. We now want this angle over here. Well, think about your symmetry. That reference angle right there is going to stay the 0.197, but we want the angle on the other side. We want that angle. That's our angle x. So x would actually be equal to not 2 pi, helps me if I do it correctly, pi minus our reference angle, which will come out to a nice approximate of 2.944. And that makes sense. That's about between 3.14 and 1.5, which is our approximate, which would be in quadrant 2. Check, looks good so far. So we're now going to take our answer from part C and figure out sine and cosine. So sine of that 2.944 and cosine of 2.944. And we would want to make sure we remember to put our calculator in radian mode. I would actually probably pull exact values this whole time, but just for the sake of having it written down, this would come out 0.196, a positive value, just like we thought it would be, and cosine comes out negative 0.981, negative value, good. Everything so far is looking like what we want it to look like. And then last but not least, we're asked to sketch and then label the angle. Answers for part C and D, label our angle and our points. So remember, sine is our sort of y coordinate, and cosine is our x coordinate. So there's a few different ways we can draw this in. So I'm going to start and just get my sort of coordinate plane, draw in a very poorly drawn circle. So my angle should be in quadrant 2. And so this angle would be angle x, which we found was equal to 2.944. And that there's sort of then two different ways we can label our sine and cosine. So I'm going to label them both ways. So one way is that I could just make a coordinate point. So I'd have my x coordinate of negative 0.981 and my y coordinate of 0.196. The other way would be to sort of show, okay, that vertical distance right here, that's going to be 0.196, and this horizontal distance right here, that's going to be negative 0.981. And I sort of like drawing it in both ways to get sort of a total visual representation of what's going on. So this is a little more complicated way of looking at inverse tangent to find angle measures, and then sort of adding in some of what we already knew with our other trig functions. So, nothing's sort of going away. We're spiraling sort of a little more and more and more. And just like with sine and cosine, we're also going to solve some equations with tangent and using our sort of inverse tangent. And the process is going to be pretty similar. And sort of thinking about how to approach these questions. So we're looking for all the solutions between 0 and 2 pi. Typically there will be 2, unless, we change the sort of frequency. And in all cases, we sort of want to set it up so that we get tangent by itself, so then we can use our inverse tangent to find the angle measure and then work from there. So here I'm going to divide both sides by 2, and so it tells me that tangent of theta equals 0.25. So I want the angle that would get me this particular slope output. So I'm going to use inverse tangent. and that's going to come out with 0.24497, and I like to write some extra decimals here. Now, if we're thinking about a tangent graph, remember, this is where I like to draw my little pictures. This slope would get me an angle in quadrant 1, which I got an output there, but I also have a matching angle in quadrant 3. Now, when it comes to our tangent function, if you remember, your period equals pi. So if I want this next angle over, one way I can figure it out is simply take my angle in quadrant 1, and I'm going to go 1 period further along the way, which would be pi, and I would end up with 3.386. And so my two solutions to this one, theta could equal 0.245 and 3.386. Now, with all equations, I do like to double check in the graphing calculator. So let's just take a look at what this would look like. So you want to make sure we're in radian mode. And so if I type in 2 tangent of x, and then we want to know when that's going to equal 0.5. And so if you take a look at your tangent graph here, you'll notice this one, that 6.52 is past our 2 pi, but we got our sort of two solutions here of 0.245 and 3.3876. It's a little bit of rounding. And so check, we have our solutions, they match the graph, we're all good to go. The next problem is going to be set up similar. We're going to sort of go through the same sort of process. Start by getting that tangent by itself so that we can find that angle measure. And so if I have 1/3 here, I'd multiply by 3. So tangent of theta would actually equal -6. And if this was a sine or cosine graph, you'd be like, oh my goodness, tangent can never equal -6. But yes, it can, because it's a slope, and a slope can be -6. So I'm going to take arctan of -6, and if I put that in the calculator, I would find out that it would get -1.4056. And you're like, well, that's my angle in quadrant 4 that has that slope, and our matching angle will be in quadrant 2. Now, keep in mind, this is not in our domain. So we need to get to our angles in the domain. Well, 1 period later would put me in quadrant 2. So if I add pi to that, I'm going to get that angle in quadrant 2 of 1.7359. And then if I add pi again, I would get to the positive version of the original angle that my inverse trig popped out with, 4.8775. And so our two solutions here, 1.7359 and 4.8775. One angle in quadrant 2, another angle in quadrant 4. Check, that makes sense. I could double check by graphing it, but hopefully this gives you a sense of what is a tangent function, how we use inverse tangent to sort of find angle measures and other things like that.